the fascinating world of food flavors. Welcome to the incredible world of food flavors, a universe that combines taste, aroma, chemistry, and even biology to create the delicious sensations we experience in our meals every day. In this video, we'll dive deep into what makes our food taste the way it does, explore the chemistry behind flavors, and uncover the role of natural and artificial flavor compounds in enhancing our culinary experiences. Flavor is more than just taste, it's a multi-sensory experience. It's the sensation we feel when food or drink enters our mouth, involving not only our sense of taste, but also smell, touch, temperature, and even pain receptors. Flavor is essentially the sum of all the characteristics of a substance that creates this unique sensation. Flavor is broken down into taste and aroma. Taste is sensed on the tongue through specialized protein receptors. The basic taste categories are sweet, sour, bitter, and salty. In addition to these, nerves in the mouth can also detect metallic and astringent sensations. Aroma comes from volatile compounds released by the food, which are sensed in the nasal cavity, either through sniffing or while chewing. Flavor enhancement and umami. Have you ever wondered why some foods taste so satisfying? That's where flavor enhancers come in. One of the most fascinating of these is umami, a Japanese word that translates to deliciousness. It's primarily associated with amino acids, especially glutamic acid. Umami is now recognized as one of the primary tastes, alongside sweet, sour, salty, and bitter, because it has a unique receptor site. Also, its taste quality is distinct and is not reproduced by mixing other primary tastes. It also functions independently of the other four tastes. Monosodium glutamate, MSG, is a well-known umami flavor enhancer. MSG has a unique taste, often described as savory, but distinct from meaty flavors. It's highly effective even in low concentrations, making it a staple in enhancing the taste of foods. Interestingly, MSG is now produced from natural sources like gluten, of wheat, beet sugar, waste, and soy protein. Meltel is another fascinating flavor enhancer used in chocolates, baked goods, and instant coffee. It not only adds sweetness, but also has antioxidant properties, extending the shelf life of roasted products. Natural versus artificial flavors. Flavor compounds can be classified into two categories of natural and artificial. The natural flavors are derived directly from plants or animals. These can also be produced enzymatically or chemically. The artificial flavors, however, are not natural. They are made from chemical compounds, often esters, that taste closely similar to natural flavors. For instance, a combination of isobutyl formate and isobutyl acetate creates a raspberry-like flavor. Now, let's have focus on the chemistry of flavors. Flavor chemistry is truly fascinating. For example, specific chemical reactions, such as the Maillard reaction, produces unique flavors. Glucose plus glutamic acid creates chicken-like flavor. Glucose plus lysine makes burnt or fried potato. Fructose plus methionine makes bean soup-like flavor. Artificial flavors often rely on esters, which provide fruity aromas. For example, green flavors are derived from citrus and herbal compounds, offering refreshing tangy notes. Brown flavors, like caramel chocolate or coffee, come from caramelization or roasting. Certain tastes are more complex than they appear. Bitterness comes from compounds like alkaloids, flavonoids, and certain amino acids. For example, grapefruit's bitterness is due to neuringin, a compound that can be debitted enzymatically. Saltiness depends on the ionic structure of salts. Sodium-based salts, like table salt, are salty, while others, like potassium bromide, are salty with a bitter aftertaste. How about hotness? Compounds like capsaicin in chili peppers and gingerol in ginger create the sensation of heat or pungency. Have you ever experienced sunlight flavor? Ever noticed how milk develops an odd hay-like flavor when exposed to sunlight? This is called sunlight flavor, caused by a reaction catalyzed by riboflavin. Interestingly, removing riboflavin can prevent this flavor from forming. In conclusion, flavor is an intricate blend of science and sensory experience. Whether it's the natural sweetness of fruits, the savory depth of umami, or the precise creation of artificial flavors, chemistry plays a crucial role in making our food enjoyable. Next time you take a bite of your favorite meal, think about the incredible science behind those delicious flavors. Thanks for watching this video. Please like, subscribe, and share it with your fellow flavor